Hi everyone, welcome to our presentation. We're Group 12 and we're going to be talking about the TQM-based approach to quality failures at Toyota. Just a little introduction. Toyota is a top global automaker headquartered in Aichi, Japan. Its success also comes from the Toyota Production System, or the TPS, which uses lean methods in order to eliminate waste as well as improve efficiency. They also have a strong focus on continuous improvement, which is why Toyota has been known for its quality. In this project, we'll look into the recent quality problems and apply TQM and Six Sigma tools to find root causes and suggest improvements. Just a little information about quality issues. In 2009, there was unintended acceleration, which led to recalls and fatalities. Additionally, accelerators, pedals, and floor mats were the simple cause. Faulty fuel pumps caused many 2020 Toyota recalls. Engine stallings and crash risks due to fuel pump issues. Recent 2025 recalls affects 2013 to 2020 Toyota Lexus vehicles, and then supplier quality control show possible vulnerabilities. As for some TQM tools that we will be using, we're going to be using the Pareto chart, benchmarking, QFD, the cause and effect, and then the control charts.
So after we conduct our Pareto analysis, the most critical issue is power window switch fires, which impacts 47.3% or 4 million vehicles and poses a significant fire risk. Battery tray issues affect 23.7% or 2 million RAV4 models, and those can cause electrical shorts. And then fuel pump defects impact 21.3%, which is nearly 1.8 million vehicles, leading to engine stalling. Toyota should prioritize a complete redesign for power window switches, use more durable materials for battery trays, and tighten fuel pump supplier controls with increased testing. Compressive supplier audits and rigorous in-house testing are needed for airbags and brakes, and addressing these main issues is crucial for safety and quality. Toyota utilizes benchmarking to address recent quality concerns highlighted by a 2024 certification scandal. Process benchmarking against Honda aims to strengthen testing and reduce over-reliance on automation, reinforcing their lean principles. Financial benchmarking against Tesla seeks to identify hidden quality costs and improve supplier oversight despite the record 2025 revenues. Performance benchmarking against Lexus targets improved customer satisfaction and in-car tech reliability after a decline in the JD Power IQS. Product benchmarking against Subaru focuses on enhancing durability and reducing recalls related to issues like power window switches and transmission failures by analyzing competitor strategies and strengthening testing.
Another TQM tool that we used was the cause and effect, or the Ishikawa diagram. It's also known as the fishbone diagram, and this is used to organize potential root causes of these issues. This tool also helps us identify what might be contributing to the defects and groups them into four key categories: materials, methods, manpower, and machines. And these are all part of the five M's of management in lean manufacturing. Additionally, we have our fishbone diagram here, which has the four main causes: manpower, machine, method, materials. And then we also included some short sub causes. For manpower, we have inadequate response times, leadership communications, training, and supply monitoring. As for machines, we have outdated systems, inconsistent testing equipment, defective machinery parts, and error detection on automation. For methods, we have delayed recalls, risk checks, verification on fixes, poor communication, and then also no customer data in identifying issues. As for our last cause, we have materials, which it consists of supplier issues, low quality materials, as well as part durability and untested material consistencies. And these all lead to the quality problem of defective products, which results in the recalls and the crashes.
For our control chart, we built a C chart to track how many Toyota fuel pumps recalls happen each month in 2024. We pulled the raw numbers straight from the NHTSA's public recall database, put 1 month per row, and posted the 12 counts into Minitab because each month is the same opportunity. A C chart was the right tool. Minitab calculated the average count 2.5 and set the upper control limit at about 5.7. Next slide. 11 months sat safely inside those limits, but August showed 6 recalls and jumped over the line. That's a special cause signal. And what that means is that the recall process is mostly stable, yet August tells us a supplier or a quality assurance slip happened and needs a fix. Going forward, any new point above that limit will warn us long before a big recall snowballs.
Hello, my name is Gavin Gonzalez. I'll be reading my part of the project, which was the QFD. I developed a QFD, a quality function deployment model, and I gathered data through a Qualtrics survey, which asked the participants one their most recent vehicle brand, ranging from Hyundai, Honda, Subaru, Ford, and an option for other car manufacturers. And then I had two questions having a scale rate 1 to 5 on six key attributes, one being safety, reliability, recall, notification, build quality, durability, transparency on their own vehicles, and then upon what they would like with a vehicle that they would purchase in the future, and then also add an option for open-ended feedbacks and strengths and improvement areas for Toyota or for any other companies. And the QFD outcomes we found were top customer priorities, obviously all the importance properties, functional requirements mapped were technical areas like safety audit, supplier QC, automation, and assembly were evaluated for their impact on meeting customer needs. We had competitive insights. Toyota actually performed well, but lagged in real-time recall and assembly automation compared to their number one competitor, Honda. Calculated priorities like safety audits and supplier QC had the highest absolute and relative weights, indicating key areas where investment will yield the most customer value. And this is all displayed on the QFD that was developed over this research process.
So for our action plans, our first action plan is the power window switch redesign. Our first action targets the window switch fires, the biggest slice of our Pareto chart. It is rated a high feasibility because it's low risk, quick payback, and the changes are totally under Toyota's control. Our second action plan is the fuel pump supplier capability upgrade. The C chart spike in August points straight at the fuel pump supplier. Most of the costs sit with the supplier, and Toyota's contact let it charge back for defects. So the supplier has an incentive to cooperate. Success is simple, which is to keep monthly recalls under the 2.5 average for 6 months straight. The mix of quick containment and shared costs makes the plan very doable, so it's high to moderate feasibility, mainly depending on supplier follow through. Our third action plan, uh, we tackle battery tray failures, which is the second biggest issue. We'll switch the stamped steel tray to a glass-filled polypropylene composite, uh, and composite trays are already used by competitors, so the tech is proven, but we'll need new tooling and crash tests. Costs even out because the composite resists corrosion and cuts future warranty claims because it needs more tooling. Cross-team coordination and time, we grade this one as moderate feasibility, but the expected 75% cut in warranty claims justifies the effort.
To conclude, we found that the power windows fires, fuel pump defects, and battery tray failures were the main quality issues. And if we were to use TQM tools like the Pareto analysis, fishbone benchmarking control charts, we are able to identify the root causes and then develop the action plans. And the action plans, as stated earlier, redesign power window switch, upgraded supplier process control for fuel pumps, and an improved battery chain design can help lead to real improvements. And here are our references. Did you pause?